Mrs. Diamond is back, and she has another warm-up question for her students to answer. Mrs. Diamond's students are back too, and some of them have not learned their lesson and decided to skip doing the warm-up today. Mrs. Diamond's wheel of name is back as well, and it is here to randomly call on students as needed. When Mrs. Diamond asks for volunteers for the first question, so back to the wheel of names we go. This time, what are the chances the wheel lands on someone who has the letter A or E in their name? Well, if these were mutually exclusive events, to get the probability of A or E, we would simply add the two probabilities together. So let's try that. First, we will count the number of names. There are 7 total names on the wheel. How many of those names have an A in them? Jason, Juan, Frankie, and Cassie. 4 names. So the probability of the wheel landing on someone with an A in their name is 4/7. Now for the second event. How many students have the letter E in their name? Cassie, Frankie, and Ben. 3 names. So the probability of the wheel landing on someone with an E in their name is 3/7. So if we were to add the probabilities of A to E, we would get 4/7 plus 3/7 equals 7/7, which is 1 or 100%. But wait a minute, that doesn't make any sense, because that would mean that when Miss Diamond spins the wheel, she is 100% going to pick someone with an A or E in their name. But what about Kim and Chris? They don't have an A or E in their name, yet 100% makes us feel that no matter who the wheel lands on, they will have an A or E in their name. Time out. Let's talk probability. The probability of the wheel landing on someone with an A or E in their name is actually an example of overlapping events, not mutually exclusive event. An overlapping event is a concept in probability where 2 or more outcomes share at least one common characteristic or outcome. Unlike mutually exclusive events, these events can happen simultaneously. This particular example with the wheel is overlapping because the wheel can land on someone with an A and E in their name at the same time. In other words, there are people in the wheel who have both A and E in their name. The probability of overlapping events is calculated by using the formula probability of event A plus the probability of event B minus the probability of event A and B at the same time. So let's look about what we know. The probability of the wheel landing on someone with an A in their name was 4/7. The probability of the wheel landing on someone with an E in their name was 3/7. But there is an overlap. How many people are on both lists? Well, Cassie and Frankie are on both lists, so the probability of an overlap is 2/7. Since there's an overlap, we're going to use a different formula to calculate the probability. The probability of A or E is going to be an overlapping probability. So the probability of A in their name plus the probability of E in their name minus the people who have both A and E in their name. The probability of A, 4/7, plus the probability of E, 3/7, minus the people who have A and E in their name, which we figured to be 2/7, for a total probability of 5/7. So the probability of the wheel landing on someone with an A or E in their name is 5/7. Let's think about why that makes sense. We'll circle the names of people who have A in their name: Jason, Juan, Frankie, and Cassie. Now we'll circle the people who have E in their name: Ben, Frankie, who's already circled, and Cassie, who's already circled. How many names are circled? 5/7. This one makes a lot more sense. Thanks so much for watching, and don't forget to raise your hand in class.